continue our discussion with the trig functions of any angle. So first we're going to review theta and what that looks like in standard position. So just a quick reminder, standard position means your angle is starting on the positive x-axis, and that angle is going to rotate clockwise, and that rotation clockwise sweeps out an angle theta. Okay, here's our initial position, here's our standard position, or excuse me, our terminal position on this side. All right, well, when we do that, we actually end up with a coordinate on the unit circle if we're in a coordinate plane. And that coordinate we're going to call xy. And if we were to draw a right triangle from that coordinate, dropping it down here and using this length as our base, this is our value of x, and this is our value of y. So y is here, and x is here in terms of the coordinate x, y. Okay, so we have a length of y, a length of x. We have the coordinate x, y on the axes there. And so when we're thinking of this right triangle in terms of theta, the y side would be our opposite side. The x side would be our adjacent side. And the radius would be our hypotenuse. Okay. And so if we're putting together our trig functions, and we remember the phrase SOHCAHTOA, oops, got to spell it right. Sine is equal to the opposite over the hypotenuse, so y over r. Cosine is equal to the adjacent over the hypotenuse, or x over r. And tangent is equal to the opposite over the adjacent, or y over x. So another way to think about these, cosecant theta, remember that's the reciprocal. So if we think of these as the reciprocal functions for cosecant, secant, and cotangent, cosecant theta now is going to be r over y. We just take the reciprocal of sine. And secant is going to be the reciprocal of cosine, so r over x. And cotangent is going to be the reciprocal of tangent, so y over x. Just a really quick review and some guidelines. Just remember that whenever we know our radius isn't going to ever be 0, but whenever you have a different value on the bottom, probably want to put that restriction. X can't be 0 here. You know what? There should have been x over y. There we go. Y cannot equal 0. And here, x cannot equal 0. And y cannot equal 0. Like I said, we know the radius isn't going to be 0 because that's the length there. Okay? Otherwise, those are undefined if they equal 0, right? Okay. So let's go ahead and kind of evaluate this. So if I had a coordinate negative 5, 12. Okay, so I'm going to put it in the correct quadrant there, negative 5, 12. And I want to think of an angle being swept out by theta from standard position. That would give me my endpoint right there. Okay, so here's angle theta. I get to negative 5, 12 as a coordinate on my circle. And really, what I'm thinking about is I need to use a reference triangle to figure out some lengths here. Negative 5, 12, if I draw a line down to the x-axis, I can make this triangle right here, this right triangle. Okay, so I'm going to go ahead and take that right triangle out and just draw it off to the side here. And since I'm at the coordinate negative 5, 12, I know that this length is 5 and this length is 12. Now I could use the Pythagorean theorem, a squared plus b squared equals, in this case, that's our radius, so r squared. Or if you're really good with your Pythagorean triples, you know that this is equal to 13. Okay, but you can use Pythagorean theorem for it to find that r is equal to 13 as well. Okay, I'm not going to show that because I know you can do that. Okay, so that means I have this triangle. I could label it here if I want, 13. Okay, and my angle theta, and let negative 5, 12 be a point on the terminal side of angle theta in standard position. Evaluate the 6 trig functions. So what I know then is sine theta, which we just went through, is equal to y over r. And cosine theta, we just went through, is x over r. And tangent theta, which once again we also went through, is y over x. You can go ahead and substitute the correct values in for y and x and r, right? So here's our x. That's our x value, our x coordinate. Here's our y value, our y coordinate. Now you'll notice that our x coordinate and our x on the triangle are two different things. One's negative and one's positive. We can't have a negative length, so we're using our positive value here. But when you substitute in a x, y value, you really want to just use these two values. You want the negative 5. So I'm going to go ahead and substitute that in as negative 5 over 13. And the reason that's important is because if you use positive 5, then you're talking about a point that's over here, which is a different length of theta, right? That would mean theta only goes that far. So rather than being maybe a, I don't know, 110 degree angle, you're dealing with possibly an 80 degree angle or something. Okay? So negative 5, 3 for x. Y is 12 over negative 5. And y here, 12 over the radius, which is 13. Okay? So those are your values. Which means if I take the reciprocal functions, cosecant theta is going to be equal r over y. Secant theta is going to be equal r over x. And tan theta is going to be equal to x over y. And so throwing these guys in, or just taking the reciprocals, really what you're doing. It's 13 over 12. It's 13 over negative 5. And it's negative 5 over 12. And now you've evaluated all 6 trig functions there. All right, let's go ahead and take this another step further, okay? So special angle relationship. So in a previous lesson, we talked about if we had a right triangle in a coordinate plane and the radius was 1, okay, and we calculated all the other sides for our special right triangle. Remember, our relationship here is this side is 2x, this side is x, this side is x root 3 in a special right triangle. And so we could say, well, if 2x equals 1, then 1x is actually a half, right? We solved this equation here for x, and that makes this equal 1/2 root 3, or root 3 over 2. Okay, so I'm going to get rid of that, I'm going to get rid of that x, and get rid of that 2x. That becomes my relationship when I have a radius of 1. And that radius of 1 is important because we're going to be talking about a 1 unit circle here in a minute. And the thing that I really want to point out here, if this is 1/2, note that this is my x value, this is my y value, this is a coordinate up here, this is a point. That coordinate has a length, or an x value of 1/2, and a y value of root 3 over 2. We can throw in those same things over here. This is 1, which is going to make our shorter side in a 30, 60, 90, 1/2, and then root 3 over 2. So we'd end up with a coordinate root 3 over 2, 1/2. Okay, so the difference on these, this was when we had a 60 degree angle. We had that coordinate. So maybe we should write that up there. So at 60 degrees. This one, theta is 30 degrees. So at 30 degrees. When we go over to the 45, the relationship changes. We still have a 1 here. If you recall, this side is root 2 over 2 and root 2 over 2. The way I get that, if this side is 1, and then we're in a special right triangle, and let me kind of back up just a little. This side is x root 2, when this is x and this is x. So if we solve this equation, 1 equals x root 2, you'd find out that x equals root 2 over 2. And root 2 over 2. Okay. And so then you would, sorry about that, then you'd have that relationship there. So this coordinate up here would be x is root 2 over 2. Y is root 2 over 2. And that's at, well, theta is 45 degrees there. We're going to use those here in a minute, but before we do that, I want to review our radian measures as well. So remember the relationship between degrees and radians. Okay, 180 degrees is pi radians, right? So 180 degrees equals pi radians. Okay, and we can use a ratio to figure out or convert between radians and degrees. We could say 180 degrees over pi radians equals degrees over radians, and we can convert between radians and degrees that way using that proportion. We've done that before. Okay, so what we're going to do is we're going to go ahead and convert these degree measures. So 0 degrees, we should know, is 0 radians. That one's pretty easy. We'll just call them rads. 30 degrees, well, I'm going to show you how to use your conversion again, or go through that just real quick. That's not right. 30 over r is equal to 180 over pi. You can cross multiply, so that gives you 30 pi equals 180r. Divide both sides by r, or by 180, excuse me, you get r is equal to 30 pi over 180. So r is, well, 30 reduces to 1, 6. So we get pi over 6. So there are pi over 6 radians there. Now it's a lot easier if you think of it intuitively, right? We know if there's 180, or there's pi radians in 180 degrees, then if I divide 180 by, well, 30 goes into 180 6 times. So there's 6 30s in 180. So we'd have to also divide the pi by 6. That's how we get pi over 6. So let's try 45 intuitively, okay? If there's 180 degrees in pi radians, right? And I'm going to 45. Well, how many 45s are in 180? Yeah, there's 4. Okay? So that means I am dividing 180. You could think of 45 as like 180 divided by 4. That's 45. Well, that just means you'd have to divide pi by 4 also. And that's how many radians there are. Okay, we could try with 60 as well. How many 60s go into 180? Well, you could rethink of that as like, well, that's just 180 divided by 3. Well, that means you're going to have to take pi and also divide it by 3. Pi over 3 radians. How many 90s are in 180? Well, that's just 180 divided by 2. Right, so you're going to take pi and divide it by 2. And that's how many radians are in 90. So you could use, I mean, this way, the way I just showed you works really well if you're using special angles or angles that go into 180 easily. Or you could, I mean, keep converting like that as well. But you use these angles so often that you're going to have to memorize those anyway. We're going to fill in the unit circle, and I'll show you where we're going to use those angles. let's go ahead and take a look at this. We're going to fill in the unit circle and all radian measures, all coordinates, all degree measures of that unit circle. So the first thing I want you to do is we're going to go through and we're going to put in our degrees. Now I'm going to put them inside here. So I'm at 0 degrees, 30 degrees, 45 degrees, 60 degrees. Try to be really neat with this. 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees. So notice I'm counting by 30s, but I also have these 45s in here that I'm dealing with. So I'm going to continue to count by 30s and skip my 45s in the middle. Okay, so 30, 60, 90, 120, 150, 180, 210 degrees. And there's a 45, we're going to skip that. 240 degrees, 270 degrees. So really I'm counting by 3 and adding a 0, right? 300 degrees. Skip the 45. 330 degrees. And don't forget 360. Okay, now I can count my 45. So 45, 90, 135, 180. Then add 45 more is 225. And then 270. And add 45 more, we get 350. And then we obviously have our 360. Okay, so degrees should be pretty easy to get. Now what I want to do, and this is going to get a little messy, but I do want to point out why we had those special angles a minute ago. So I'm going to draw a triangle that starts from the standard position right here, and it goes out to my 30-degree angle. Okay. Here's theta. Now I'm going to do this multiple times, so I'm going to quit highlighting theta, but that's what I've got there. I'm going to use different colors for my other ones. Okay? And what's important to me is to be able to look at that and drop down and go, well, that right there is a right triangle. And that is a special right triangle. Let's say 30, 60, 90 right triangle. So here's theta. That's that 30-degree angle. Notice I put the 30 up here, but that's referencing this angle. That's what the 30 means. Okay? Well, remember, 30 degrees had a special coordinate. It had an x length of √3/2 and a y length of 1 when r is 1. Well, when r is 1, that is what a unit circle is. So what is a unit circle? Oops. I'll get a close-up there. A circle with center, or maybe we should just say centered at the radius, or centered at the origin, with radius equaling 1. That is a unit circle. Okay? And so if this is 1, our special angle measures were √3/2, 1/2. That was the length. So this length was √3/2. This length was 1/2. So that gave us the coordinate √3/2, 1/2. Okay. Well, at 45, let's go ahead and switch up our colors. We had a 45, and I'm going to erase this one as well. We now have a reference angle, an angle that goes out to here, and rather than having 30, it would go like this, and it would be 45 degrees. Okay, well that 45-degree angle, when we drop the altitude here, with a right angle, this had a special coordinate. That special coordinate was √2/2, √2/2. All right. Well, we also had one other, and it was, let me use a different color here. If I'm colorblind, it's a little harder, but we'll go to 60 here. And now our theta does this, it goes to 60. Okay, and we have that dropping down. Well, that 60-degree angle, that had a special angle measure. It was 1/2, or special coordinate, 1/2 root 3 over 2 at 60 degrees. All right, we'll erase the 60 there. Now, you've got your 3 reference triangles that are special triangles. We also should know a coordinate right here. If this length is 1, then the ordered pair at 0 degrees is 1, and the y value is 0. Right? And we actually know the coordinate up here at 90 as well. That is 0 on x and 1 on y. Now the cool thing about this, you can complete the whole unit circle. Right? You can rotate the root 3 over 2 over here, and the 1/2, because of the, I mean, this is the same triangle. It's just dropping down to here, as this one over here is. Right? So this is root 3 over 2, 1/2. That side just reflects over. This point just reflects over here. This is root 2 over 2, root 2 over 2. This one reflects over. This is 1/2 root 3 over 2. Okay, and this is, yeah, that one just reflects over 1, 0. Okay. Now, for those of you like yelling and screaming right now, hold on, that's not right, that's not right, that's not right. Yeah, I know. This quadrant here is a positive quadrant. That means both x and y are positive. This quadrant here, quadrant 2, this, by the way, is quadrant 1. Quadrant 2 is a negative x value, positive y value. So just go through and put negatives in front of your x's. Your y's stay positive. There. Now you're correct. Okay? And so if I want to find 210, I can rotate these down, and I could go, well, that makes this one from here to here. That's 1/2. And again, root 3 over 2. And notice the 45s are the root 2 over 2, root 2 over 2, and we kind of highlighted those by putting a line under them when we were writing the degrees in. And then negative, or excuse me, 1/2 root 3 over 2. I know that I forgot the positives and negatives. I'll get them here in a minute. And 0, 1. Okay? This quadrant, quadrant 3, is the negative quadrant, totally negatives. So that's negative and that's negative. And then we have our last set. Now I know you can reflect those points. I'm going to reserve the last set for when I show how to do this, how to fill this out using patterns. Okay? So I'm going to do that right now. And I want you to know you're going to have to memorize these. So you could just memorize them all as are and learn to reflect them. You just memorize these right here, learn to reflect them. That is fine. If you forget, there is a pattern involved, and I'll show that by kind of going through and maybe listing it kind of on the outer edge here for a minute. We know that we start at 1, and I am going to call 1 root 4 over 2. And I'm going to call 0 root, well, I'm not going to call it anything yet. We'll just call this root 4 over 2. Root 3 over 2. Root 2 over 2. Root 1 over 2. So notice I'm just counting. over 2 is root 4, root 3, root 2, root 1, root 0 over 2. And then I'm going to count back the other way. So I'm at root 0 now. I'm going to go to this one and go root 1 over, or excuse me, root 4 over 2. Root 3 over 2. Root 2 over 2. Root 1 over 2. Root 0 over 2. Notice by doing that, what you've done. All you have to do is memorize this first quadrant, right? Because everything reflects. Well, if you can remember A, it's just start at root 4. Root 4, root 3, root 2, root 1, root 0. Root 4, root 3, root 2, root 1, root 0. You can just remember this starting point, root 4, root 3, root 2, root 1, root 0. And then root 4, root 3, root 2, root 1, root 0. You can remember that starting point. These just reduce. What is the root of 4? Well, it's 2. What is 2 divided by 2? It's 1. What is the root of 0? It's 0. What's 0 divided by 2? That's 0. What is the root of 3? Well, you can't do anything with it. So it's root 3 over 2. What is the root of 1? It's 1. It's 1 divided by 2? It's 1 half. Root 2 over 2, root 2 over 2. Root 1, there's 1. 1 half. Root 3 over 2. Root 0, there's 0. Root 4 over 2, that's 2. What is that? That's 2 over 2, which is 1. That's a quick shortcut. Saves you some time. Okay? Now, I didn't actually walk all the way around the circle, so I guess I should actually fill in quadrant 4 here. All right? If you want to use that pattern, do it. I really think it's helpful. If not, so be it. You don't have to. That's completely up to you. But this quadrant right here is your positive negative quadrant. Okay? And so we're going to have still our 1 half and our root 3 over 2. And we're going to have our root 2 over 2, root 2 over 2. And we're going to have our root, our root 3 over 2. And 1 half. And then don't forget your 360, even though you're repeating the same coordinate. And then make sure you change your signs, right? All y's are negative. Negative, negative. Make sure a negative doesn't look like part of the square root symbol. Okay? You've now filled out all degrees and all coordinates of your unit circle. All right. Now I've got to erase this stuff so I can fill out the last piece. So hopefully you have that. If not, back up the video and write it down, take notes on it if you want to use that. It's helpful, been helpful to a lot of students in the past. The last thing we need is our radian measures, and we have to add those in there. Well, we came up with the radian measures of a 30, right? 180 is pi radians. 360 is 2 pi radians. 0 is 0 radians. Well, if 180 is pi, 30 goes into 186 times. We have to divide 180 by 6 to get 30, so we're going to divide pi by 6. Okay, that's pi over 6. All right. And so if you want, I could show you a shortcut here as well. But I'm gonna go through our 60. We have our 60. We did that over here, right? That's pi over 3. Hopefully the shortcut I showed over there will help out. This is going to be pi over 2. And this one is pi over 4. Okay. Well, then you have to keep going. You can't just reflect them over. So the radian shortcut helps you out even a little more. All right. Now here's what I would do. Remember when I was doing degrees, I was counting by 30s, and then I counted kind of by 45. Well, I'm going to count by 30s with radians. So 30 is 1 pi over 6. Next 30. So 30 is 1 pi over 6. 60 is 2 pi over 6. What is 2 pi over 6? Yeah, that's pi over 3. 90 is 3 pi over 6. What is that? Well, that's pi over 2. So 90, we go to 4 pi over 6. 5 pi over 6. Oops, got to go to 150 for 5 pi over 6. Running out of room over on this side. 6 pi over 6. 7 pi over 6. I'm going to have to write that right here. Um, 8 pi over 6. 9 pi over 6. Just counting by pi's over 6. 10 pi over 6. 11 pi over 6. And 12 pi over 6. And I have now completed my rotation. I need to reduce, right? Well, we've already reduced 2 pi over 6. Reduced it, that was weird. Okay, it's pi over 3. We've reduced 3 pi over 6, pi over 2. 4 pi over 6 becomes, well, 2/3, so 2 pi over 3. Okay, so these are the correct ones here. 5 pi over 6, 6 pi over 6 reduces to pi. 7 pi over 6, 8 pi over 6 reduces to 4 pi over 3. And we don't want to confuse there, so let's write it down here. 4 pi over 3. Okay. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 becomes 5 pi over 3. And then 11 pi over 6 and 12 pi over 6 reduces to 2 pi. You might be going, well, what about the pi's over 4s? Well, what about them? We have 1 pi over 4, 2 pi over 4. I'm not going to write it, but 2 pi over 4. This one's 3 pi over 4. The reason I didn't write 2 pi over 4 because it reduces pi over 2. Four pi over 4, which is pi. 5 pi over 4. 6 pi over 4, which is 3 pi over 2, and 7 pi over 4. And then 8 pi over 4 is 2 pi. Now you can make a cleaner version of that, but that is the unit circle. All degree, all radian, and all coordinates. And you have to memorize them. You'll be using them a lot. A few definitions. Quadrantal angles are angles that lie on an axis. So for instance, in degree form, that would be our 0 degrees, our 90 degrees, our 180, our 270, and our 360. Keep in mind another way to think of sine, cosine, and tangent. Remember, sine is always our length on y. So sine is always you can think of it as a y value, right? Sine is y over r, and when the radius is 1, it's y over 1, so sine theta is just y in the unit circle. And cosine is always x over r, and when r is 1, that just means x over 1, or in the unit circle, cosine is always x. And one thing to know about tangent, if I wanted to find, I'm going to just use my 30 degree triangle right here. Okay, so I'll sketch that out right here. The 30 degree triangle that we have. Right, just to make this point. Oh my goodness. Oh, yeah. Okay, so there's theta. And we know theta in this case is going to be 30 degrees. And we know this is a 1 unit circle. And this is our y value. This is our x value. Okay, well, tangent, opposite over adjacent. So of 30, that would be opposite over adjacent, which would be y over x. Well, what is y over x? What does y over x mean in the unit circle? Well, in the unit circle, and I'm going to change this back to theta now. In the unit circle, y over x is sine over cosine. So what does tangent actually mean? Dude, tangent is sine theta over cos theta. And that's true in any or any time you're using tangent. It's sine over cosine. That's the ratio for tangent. Neato burrito, man. So just so you know, and this is kind of future, a little foreshadowing, cotangent then. What would that be? Well, it's a reciprocal of tangent, which is x over y, which means cotangent. Dude, That's cosine theta over sine theta. Awesome. That's just a little extra. Pretty cool stuff. Okay, let's go ahead and kind of put some of this in action while we're using special angle measures. So evaluate the 6 trig functions of theta equaling 90 degrees. Okay, well first, we're going sine of 90, cosine 90, tan 90, and then we've got our reciprocal functions from there, right? So we got cosecant, which for some reason I can't write there, cosecant 90, secant 90, and cotangent 90. All right, so if we're going 90, just remember, in the unit circle, we're going from here, rotating up. Remember this coordinate right here, that was 1, 0 in the unit, not 0, 1, 0, 0, 1 in the unit circle. Okay, and this is my x, this is my y, and so sine is x over y, or excuse me, not x over y, sine is x over r, our radius is 1, right? So sine is not x over 1, it is y over r. Let me slow down there. Sine is my y over my radius. Okay, and my radius is 1 in the 1 unit circle, so that is 1 over 1, which is just 1. You could also just say, well, I know sine is y, so it's 1. Cosine is always x, so it's 0. Tangent is always sine over cosine, right? So 1 over 0. Well, 1 over 0 is, that's not good, that's undefined. Okay. Cosecant? Well, it's just the reciprocal of sine, and so that's going to be still 1. Reciprocal of 1 is 1. Reciprocal of 0 is undefined. So if you remember back to your days of slope where you had a flat line with a slope of 0, well, the reciprocal of that is a line straight up and down, which is undefined. Okay, or you can think in terms of 1 over 0, you become 0 over 1. In this case, that is a 0 slope. So reciprocal of 0 over 1 is 1 over 0, which is undefined. Okay, evaluate the 6 trig functions for 240. Well, all right, so let's go with the sine of 240, cosine of 240, tangent of 240, cosecant of 240, secant of 240, and cotangent of 240. Well, those are quadrantal angles, right? Just like the 90 was. And so, oh no, 240 isn't. 240 is that. I was thinking 270, my bad. Okay, 240, we're down here at this point here. And so what we need to do is think to ourselves, well, 240 degrees from here to here, what special angle is that? Or special point is that? Well, 240 is negative 1/2, negative root 3 over 2. So we have negative 1/2, negative root 3 over 2. Okay, so sine is, well, that's our y value, right? X, y, so this is cosine, this is sine. So sine is negative root 3 over 2. Cosine, negative 1/2. Tangent, well, tangent becomes sine over cosine, so negative root 3 over 2 divided by negative 1/2. Well, negative divided by negative is positive. And root 3 over 2 divided by 1/2 is the same thing as multiplying by the reciprocal of 1/2, which is 2 over 1. This whole thing becomes, those cancel, just becomes root 3. So tangent is root 3. Cosecant is the reciprocal, so we get negative 2 over root 3, but you don't leave a root in the denominator, So you rationalize it, so that becomes negative 2 root 3 over 3. If you are struggling with rationalizing, you need to talk to your teacher. If you don't know how to get that root out, that's something you should know by now. So we're kind of done going over that, at least in my class, unless someone comes in and asks for help. Secant is 1 over negative 1/2, or the reciprocal, of negative 1/2, which is negative 2. And cotangent is the reciprocal of root 3, which is 1 over root 3, which becomes root 3 over 3 when you rationalize it. All right. We got it, man. Well, let's move on. Okay, let's talk about reference angles. And I've actually said them a few times in here, but let's actually define it. A reference angle theta is the acute angle theta prime formed by, so this is theta prime, by the way. Formed by the terminal. It's supposed to be an O. Side of theta and the x-axis. All right. So really what that means, if I'm in quadrant 2 and I move theta degree or theta, an angle of theta that way, and I get this terminal position. Okay. Theta prime is this angle right here. And why are we worried about that angle? Well, that helps us to draw our right triangle, right? That's the angle we're thinking about when we're looking at our right triangle. Oh, shoot. Let's go back. Sorry about that. There we go. This is the angle I want for theta prime. Okay, so that gives us our right triangle. And so we like to know that. So the way we get it is we go 180 degrees and we subtract out all of theta. So let's say this was like a 150 degree angle. We'd have to do 180 minus 150, which would mean this is a 30 degree angle. So we're taking 180 and subtracting out whatever our theta angle is, and that gives us theta prime. In radians, that would mean 180 is pi, so it would be pi minus theta. So you can use an example here. You can say, well, like 180 minus 150. To give you a 30. This would be theta. This would be theta prime. Okay, quadrant 3. So let's say we start here. And we cruise on over. We're down here now. Okay, and so this is theta. And so let's say this was 250. And I want this angle right here. This becomes my reference angle. So this chunk right here is theta prime. Okay, and so looking at that, if I need to get from here to here, how am I going to do that? Well, I'm going to start with whatever theta is. So in this case, if I had 240, I'd have to subtract out my 180. Right? That would leave me with, well, 240 minus 180 is 60. Meaning, if this was theta, this would be theta prime. So it's theta minus 180, or theta minus pi if you're in radians. Okay. And in quadrant 4, the formula is now way over here, right? Okay, there's theta. And here's theta prime. Right? So here's my angle. Kind of swap out. So in terms of that, you'd really want to know, well, 360, and I'd subtract out theta, right? So if this was, say, like 330, well, let's go 340 degrees, okay? I'd have to do 340 and subtract that from 360, that would give me 20 degrees. This would be my theta. This would be my theta prime. Okay, so it'll be at 2 pi minus theta. All right, so let's go ahead and use that now. Find the reference angle, theta prime. Well, I am going to do that. If I'm in radians, I'm going to use my radian formula. If I'm in degrees, I'm going to use my degree formula. Okay? And I first need to know where the angle is. So 4 pi over 3. Well, think of it this way. 3 pi over 3 is pi. So 4 pi over 3 is right down here, meaning I'm in quadrant 3. Okay? This is 4 pi over 3. And so I want to know this angle. And some of you can just look at it and figure it out. However, I'm going to use the formula, theta prime, I'm using the ones from the previous slide, is equal to 4 pi over 3, that's theta, minus pi. Well, pi is the same thing as 3 pi over 3, right? So if I have 4 pi, and to keep a common denominator, 4 pi minus 3 pi is 1 pi. So this angle is 1 pi over 3, theta prime, my reference angle, to make that right triangle. Okay, 210 degrees, negative 210. Let's look at that. That's going to bring me from here all the way up to in here. Negative 210. Okay, well, what I'm going to do, I'm going to think of it this way. First, I'm going to think, well, I'm in quadrant 2, but I'm going to think about what the actual coterminal angle is. So what will complete this circle? I've already traveled 210. I want to travel 360, so I'd need another 150. So my reference angle would be, or not my reference, but my terminal angle would be 150. They would end at the same spot, right? So I'm going to use 150, and I am going to use the formula for quadrant 2, which is theta prime is equal to 180 minus 150. Which should give me a 30-degree angle. And hopefully that makes sense, right? Because if I drop my right angle right here, and I make this triangle, this would be a 30-degree angle. Okay, 210, if you go back 30 degrees, you're at negative 180, which brings you right there. Okay. All right, pi over 4. Well, what quadrant is that? Well, that's quadrant 1, and we didn't have a rule for quadrant 1, and there's a reason why we didn't have a rule for quadrant 1. All right, so just so we're clear here, let me make this a little bigger so we can see it. Look, quadrant 1, your reference angle is the angle, right? Pi over 4 is your reference angle because you're going down to that x-axis. That's why we didn't have a rule for it. So if you're in quadrant 1, your reference angle is theta, just so we know. And then 315, do here, that here, it's going to bring us all the way to quadrant 4. Okay, the rule for quadrant 4 was 2 pi. Oops, not 2 pi, since we're dealing in degrees, so 360 minus 315. That gives me 45 degrees. That is my reference angle. All right, just one little piece left. Evaluating some functions without a calculator. So the tangent of negative 2 pi over 3, this is supposed to be negative 2 pi over 3. I know it that negative kind of blends in there, but negative 2 pi over 3. All right, so what I look at is I know that tangent, these are my reciprocal functions, or in this case also tangent, reciprocal functions and tangent. And the reason I put them on here is because they're not easy ones to just look at your unit circle and go, oh yeah, it's right there, or right there. So what you have to do is, like, tangent is the same thing as, we talked about it, sine over cosine. Secant is the same thing as Yeah, it's 1 over cosine. Right, it's the reciprocal of cosine. It's 1 over cosine. Cosecant is the same thing as 1 over sine. It's the reciprocal of sine. Cotangent is the same thing as 1 over tan, but we know tangent is sine over cosine. Okay, so you could think of cotangent as the reciprocal of sine over cosine, or cosine over sine. Okay. All right. So what I'm going to look at is, when I do this, I'm going to expand this. I'm going to say I want the sine of negative 2 pi over 3 divided by the cosine of negative 2 pi over 3. This should have been in parentheses as well. Okay. Well, what is the sine of negative 2 pi over 3? Well, you've got to think to yourself, where is negative 2 pi over 3? Well, you can go backwards on your unit circle, if you have that in front of you. You can say, well, I'm going to go down like 1 pi over 3 is. Right, so you go from here down to, right here. That's a pi over 3. Pi over 3 is 60 degrees, so I'd have to go back 2 of those. I'd have to go back 60, and then another 60. So negative 2 pi over 3, remember, that's going to bring you all the way back, 120 degrees back, which brings us to way over here, right? So we're down to right in here. Okay, so we've got to go to 240 degrees, which is 4 pi over 3. Okay, so you could think of negative 2 pi over 3 as the same thing as 4 pi over 3. They're coterminal. Okay, so negative 2 pi over 3 and 4 pi over 3 are the same thing. They give you the same coordinate. Okay, and that coordinate, well, sine at that point is negative root 3 over 2. Cosine is negative 1/2. So sine of negative 2 pi over 3, negative root 3 over 2. Cosine of negative 2 pi over 3 is negative 1/2. So you're taking negative root 3 over 2 and dividing it by negative 1/2. Well, I'm going to start by saying negative divided by negative is positive, so I'm going to ignore those negatives. Then I'm going to multiply by the reciprocal. And notice they cancel. So that is root 3. So the tangent of negative 2 pi over 3 equals root 3. All right. Let's deal with secant of 150. That's really saying what is we're taking 1 and dividing it by the cosine of 150. Or you're finding the cosine of 150 and taking the reciprocal is another way of thinking about it. So let's look at the cosine of 150 for a minute. Okay? It's always good if you try to do them in your head first, kind of get what you think it is. All right, and then figure it out from there. But I'm going to go ahead and switch back to our unit circle real quick so I can reference it with you. So we got 150 degrees. It'll be right here. Cosine at 150, remember cosine is your x value, so that's negative root 3 over 2. Okay? So this is equal to 1 over negative root 3 over 2. And don't let the 1 over negative root 3 over 2 confuse you. 1 over negative root 3 over 2, this just means the reciprocal of negative root 3 over 2. What is the reciprocal of negative root 3 over 2? Well, that is equal to negative 2 over root 3. You just flip it. That's what 1 divided by negative root 3 over 2 is. Then you have to rationalize. You have to get the root up there. So that becomes negative 2 root 3 over 3. Once again, if you don't know how to rationalize, like get that radical out of the denominator, you can talk to your teacher. But secant 150 is negative 2 root 3 over 3. All right. Cosecant 9 pi over 4. Well, let's look at that. 9 pi over 4, by the way, that seems quite big. That is over 180 degrees. right? You're not going to find 9 pi over 4 over here. You're going to find 7 pi over 4, 8 pi over 4. 9 pi over 4 is the same thing as pi over 4. Okay, so if you're doing cosecant is saying we want the sine value, which is our y. So we're at pi over 2, or root 2 over 2, excuse me. So this is 9 pi over 4, which is the same thing as pi over 4, which is the same thing as 1 over root 2 over 2. Remember, this just means the reciprocal of root 2 over 2, right? So that is 2 over root 2, which is 2 root 2 over 2. And then we have to cancel just root 2. Okay? All right. Last one, cotangent 315. Well, dealing with cotangent, that's cosine over sine, 315. Let's go to 315. That is root 2 over 2, negative root 2 over 2. It's a multiple of 45. Those ones are easy. You just remember what quadrant you're in. You remember the multiples of 45. Okay, so that's going to give me root 2 over 2, negative root 2 over 2. And root 2 over 2 divided by root 2 over 2 is 1. And positive divided by negative is negative. So it's negative 1. All right. Yep, that's all I got for you. Good lucky.